Okay guys, today we're starting on lesson 4 of module 1. Now I'm just going to do a quick review of what we've already learned when it comes to exponents, all of our exponential laws. We've learned that whenever you have numbers like x to the m power times x to the n power, as long as those bases are the same, then you can just do what? You can add those two exponents together. That was the first rule that we've learned. Then we've learned that whenever you have x to the m power raised to the n power, we have x to the m times n. Rule number 3, we've learned that whenever you have x to the y, remember not to the y, x times y to a certain power, it's the same thing as saying x to the n power times y to the n power. And then remember, if x is 0, then we can do 4. Remember, this was also from lesson 2. We have x to the m power over x to the n power, and x is 0 because you cannot divide by, x is not 0 because you cannot divide by 0. If they have the same base, then you can take x to the m minus n, and then 5 where y cannot be 0. Number 5 where you can have x over y to the 5th power, or to the m power. That's the same thing as x to the m power over y to the m power. So remembering all of those, let's go into a brand new idea. The 0th power, the power of 0. Meaning if I have 3 and its exponent is 0. I'll give you 2 seconds to think what you think that could be. Okay. I'm going to bet that at least 97% of you all said the answer is 0. We're going to test to see if this can actually be 0. Because let's look at the first rule that we just said. We said that if x to the m power times x to the n power were multiplied, it would equal x to the m plus n. So let's say I have 3 to the 0 power is one of them, right? I have 3 to the 0 power times, I'm going to do 3 to the 2nd power. Then following this rule, it should be 3 to the 0 plus 2, right? And if I simplified that, that would be 3 to the 2nd power because it's 0 plus 2. But if I simplify this over here, guys, 3 squared would be 3 squared times, if you say 3 to the 0th power is 0, then this would be 0, right? And then 0 times anything is 0. And 0 does not equal 3 squared. So that means that this number to the 0th power cannot be 0. So I'm going to give you a second. What else do you think it could be if I have 3 to the 0th power? What does that equal? I'm here to bet that you said that it is 3. Well, let's use one of our rules again. The reason that this cannot equal 3 is because remember that we said 3 to the 1st power equals 3? We can't have two notations that mean the same thing, because then that becomes contradictory whenever you're trying to solve something. I can't tell you that 3 to the 0 equals 3 to the 1st, because they're two different things. If they equaled each other, then I would just say that 3 to the 1st equals 3 to the 1st. This equals 3, this does not. Let's look back at one of our problems, one of our rules. If I say that n is 0, and I have, so equation 1, I have x to the n power plus x to the m power equals x to the n plus m, right? So let me replace that. I said that we're going to do those 3's again. If n is 0, we're going to do 3 to the 0th power plus, we'll do 3 again, to the 2nd power equals 3 to the 0 plus 2. So that's correct, right? All right. So simplifying that, I have 3 to the 0 plus 3 squared. And if I simplify it, it is 3 to the 0 plus 2, which is 3 squared. Oh, God. Sorry. Guys, I'm so sorry I've been putting plus. We know that the rule, that multiplication, that exponent rule always deals with multiplication. I am sorry that I've been putting plus if that was confusing to you. I have 3 to the 0th power times 3 to the 2nd power equals 3 to the 2nd power. Now I'm trying to figure out what is the value of 3 to the 0th power. Can anybody think of how I can find this value? Well, what I should do is get it by itself. And how do I do that? How do I get 3 to the 0th power by itself? I need to get rid of everything else on this side. And if this is times 3 to the 2nd power, how do I get rid of this times 3 to the 2nd power? I can do one of two things. I can multiply this whole side by 1 over 3 to the 2nd power, and these would cancel. Or I can do what? I can divide this side by 3 to the 2nd power, and this would cancel. So I'm going to do that. I'm going to divide each side by 3 to the 2nd power. I'm left with 3 to the 0th power equals, if I did it to this side, I have to do it to this side, so 3 to the 2nd power. What happens whenever you have a fraction that has the same thing on the top than on the bottom? It's the same thing as saying if I have 2 over 2. This cancels and becomes, or this simplifies and becomes 1. This simplifies and becomes 1. So that means anytime you have a number that is brought to the 0th power, it always equals 1. Because I have said that this rule is fact. This rule is true. And if I were to make one of those exponents 0, and I solved it out, my exponent of 0 and its value, base value, would always equal 1 if the power is 0. And that always applies. Anytime you have a number raised to the 0th power, it equals 1 every single time. So let's begin on our exercise. It's a very short lesson today. So I'm going to work these with you. It says, and it gives you all your first 3 rules right here. List all possible cases of whole numbers m and n for identity 1. More precisely, when m is greater than 0 and n is greater than 0, we already know that this law is correct. They want to know what other possible cases of m and n for which this first equation is still true. What they basically said, I know it's confusing to look at all those numbers and letters. They've said that whenever m, this exponent of m, or n, is greater than 0, that it works. So it says if x to the 1st power times x to the 2nd power, that will equal x to the 1 plus 2. Those numbers were above 0, so this is still true. They want us to come up with other possible cases that keep it true. Well, one of them for sure is 1 is still true if m is greater than 0, so that m right here would be bigger than 0, and n is equal to 0. What that's saying is if the exponent right here, if the exponent of m was greater than 0, so 2, and it was being multiplied by x with the n exponent being 0, then it would equal x plus m plus n, which would be x to the power m plus n, which would be x squared times 1, which is just x squared, equal x to the m plus n. M was 2, n was 0. This is still true. So this works if m is greater than 0 and n equals 0. Case 2 is if m is equal to 0 and n is greater than 0. And the same thing applies. If this 2 is n and this m is 0, same thing happens. It will equal out to be the same. And the last case is whenever both m equals 0 and n equal 0. If the exponents are 0, that still works. And how do I know? Because if I had 2 to the 0 power times 2 to the 0 power, it would equal 2 to the 0 plus 0. 2 to the 0th power is 1. 2 to the 0th power is 1. 1 times 1 equals 1 on that side. And then 2 to the 0 plus 0 power is 2 to the 0. And I know that any number to the 0th power is 1. So that also works. And then it said check that exercise 1 is correct for each of these cases. I just did that all for you, so you don't have to do exercise 2. Moving on to exercise 3, do the same with equation 2 by checking it case by case, okay? Equation 2, I'm going to leave my cases up right here so I can try out equation 2. This is equation 2, our second law. It says that x to the m power to the nth power equals x to the m times n. So let's try it. If m is greater than 0 and n is 0, what happens? Okay, x to the, well, greater than 0 do 2, raised to the 0 power, then it equals x to the second power times the 0 power, which will give you x to the 0th power, which means 1. Do this, and then it's going to have you do the same for equation 3. I'm going to skip exercise 4 because it's redundant. We're doing the same thing over and over just to prove that anytime a number is raised to the 0 power, it equals 1. Next, they want you to write, go ahead and try exercise 5 and 6 without me explaining anything. They want you to do expanded form using exponential notation. That means if I wanted you to write 1,201 in exponential notation in expanded form, remember from 6th and 5th grade, expanded form means taking the place values and showing it like this. I have 1 is in the thousands place, so it's the same thing as saying I have 1 times 1,000 gives me 1,000, plus that 2 is in the hundreds place, so times 100, plus that 0 is in the tens place, but because it's 0 times something, I don't have to put it there. And then I have 1 times 1, because that gives me the ones in the ones place. But instead, they want you to put it in exponential notation. I have 1,000. What is 1,000 in exponential notation? I know that it's 10 being multiplied by itself 3 times. I know that 100 is 10 multiplied by itself 2 times. And I know that 1 is just 1. So they want you to do it all in exponential notation. And this is how you do it. 8,374, and I just missed something about that 1 that I'm going to clear up right now. That 8 is in the thousands place, so it's 8 times 10 to the third. Plus, that 3 is in the hundreds place, so 3 times 10 to the second power. Plus, that 7 is in the 10th place, so 7 times 10 to the first power, because remember this is just 7 times 10. And then for that 4 is in the ones place, so it's 4 times, and I know I just said that we just put 1, but let's keep it in exponential notation in bases of 10. So this is 4 times 10 to the what power? What power would make this 4 be in the ones place? I need to make this number 1, and that would be by adding a 0 in the exponent. You guys go ahead and try the second one. Go ahead and pause your video. All right, I have 6,985,062. 6 is in the millions place, so I have 6 times 10 to the 6th power plus 9 times 10 to the 5th power to make it 900,000 plus 9 times 10 to the 4th power. And then I have plus a 0 is in my, wait, no, sorry, skip that. Plus 5 times 10 to the 3rd power, because it's in the thousandths place. I have a 0 in my hundredths place, so I don't have to do anything, because 0 times anything is 0. So I have that plus a 6 in my tens place, which is 10 to the 1st, and then plus 2 to the 10 times 10 to the 0th power. All right, and that is all I have for lesson 4. Go ahead and do your problem set, turn it in, and I'll see you guys tomorrow.